how do we calculate for the average atomic mass of a certain element if ever we're given the actual number of atoms instead of the percent abundance? So here in your screen is another type of problem in which you're given a sample that contains 400 lithium atoms. And in this sample, it is found that 30 atoms are actually lithium-6. Lithium-6 means the mass number of that element lithium is 6. It has an actual mass of 6.015 grams per mole. And 370 atoms are lithium-7, and lithium-7 has an actual exact mass of 7.016 grams per mole. So calculate the average atomic mass of lithium given this particular type of problem. So what do we know? First is, let's organize all the information in a tabular form, which I suggest that when you're doing this, make sure that you present a table to make it more organized and structured, and this means that you understand the problem and how to approach it. So we start with putting what element it is. So it's lithium. So we make the table, and because we have two lithium isotopes here, which are lithium-6 and lithium-7, so we will put here 6 and 7. Okay, the exact mass of lithium-6 is found on the problem, so that's 6.015. And then the other one, lithium-7, is 7.016. Okay, because we're not given the percent abundance, that means we look into the number of atoms that were given. We know that there among the 400 lithium atoms is the total in that particular sample. 30 of that are lithium-6. So what we will do now is we'll just, to get the percent, is we'll get the actual number of lithium-6 isotopes, which are 30, divided by the total number, which is 400 atoms. Then we can multiply the quotient of that by 100 to get the percent abundance. And on the other hand, for lithium-7, we got 370 atoms. So 370 atoms of that divided by the total, which are 400 atoms. And again, multiply it by 100 because it's about the percentage. So 30 divided by 400 times 100, you will now get 7.5%. And 370 divided by 400 times 100, we will now get 92.5%, in which this percentage can now be converted to decimal by dividing it by 100. So actually you can just move it right away without actually multiplying by 100 here. You can get the decimal by just dividing this the numerator and the quotient. So that's going to be 0.075 here, and this is 0.925. Okay, so now we're able to get the percent abundance. So the percentage here is being shown how to get based from the numbers that are given in the problem, because there might be some problems that will ask you for percent abundance later on. So this is one approach that you're going to do if ever you're asked for the percent abundance. So now we are ready to calculate for the average mass of lithium. So using the exact mass, and we multiply it by the decimal. So that's going to be 6.015 multiplied by 0.075 plus 7.016 times 0.925. Okay, now we're ready to input this in the calculator. 6.015 times 0.075 will give us 0.45. And then the other quantity, 7.016 times 0.925, we're going to get 6.49. Okay, so these are the products that we're going to get. And then after that, we're ready to add all the products. So 0.45 plus 6.49, we're going to get 6.94. So this is now the average weight or the average mass of lithium element. So let's check in the periodic table if we see the average mass of lithium to be 6.94. So let's go to the periodic table and let's now check and locate where lithium is. So we're now able to locate lithium. It's here. So looking at it, and let's compare what we got. We got 6.94, and we're gonna look at lithium here, and we see 6.94, 6.94. So that's the average mass of lithium considering all its isotopes 6 and 7. Okay, so that's it for now. Thank you so much for watching this short lecture video. Hope you learned something about calculating for the average mass. Till next time, bye-bye. This is Madam Narca saying don't stop learning, relearning, and unlearning. Bye-bye.